more than that, I will answer. Okay, so please ask whatever doubts you all have, please ask. Yeah, please message whatever doubts you all have one by one. Please message. I will answer them quickly. If I know, I will do it. If I don't know, there's nothing I can do. Okay, do we have class? Yeah, I'm here. Teacher is here, students are here. What else do you want? Yeah, teacher is there, student is there. What else do you want? My screen is now, doesn't matter. It's a doubt clarification class, so it doesn't matter. Whoever has doubts, please ask them. Yeah, screen is visible now. Yeah, good afternoon. Good afternoon to you all. Please ask whatever doubts you all have, ask. A question on a semicircular loop and had to find the induced EMF and heat in that case. Could you please solve that sum? Okay, there is an induced, there is a semicircular loop. Okay, last weekend test, right? Okay, let me just try to get access to it. Just a few minutes, we'll get access to it and then I will do it. So let me just go to my history. My history, it won't be there. I don't know, somehow all the NEET model tests are there, JEE model test. Just a minute, huh? 2 minutes. Research associate 1 Henry outside plastic tube such as solenoid and another. Make a solenoid using a copper wire. Now help the associate. Okay, this was a doubt. I will solve that. Semicircular wire, PQROP, the resistance R, its radius is given with POR as the diameter at a distance R from a long parallel wire AB. The current in the wire decreases linearly and the heat generated. Okay, so this question is here. So I'm looking at the options. The first option looks like mu naught R squared. Everything seems to be same between first and the second, but between second and third, instead of T squared, there is a T cubed, but none of these is also there. So, okay, I got a question. I got the question. So let's see if I can solve it. Okay, let me see if I can solve it. So now there is a wire here. Then there is a semicircular loop like this. Okay. If this angle here is theta, this area, this will become equal to R sine theta. This is also R sine theta, 2R sine theta. So some distance is given to us. 1 minute. Okay, so that is also small r. Fine, no problem. So this distance is also r. This is also r. So mu naught I by 2 pi r plus r sine theta, into the area. This area will become no pi into, it will be dx, or okay, dx into 2 times r sine theta. Okay, so I have this. So now this is the flux through the shaded region. So I need to integrate this. When I come here, theta becomes 0. So when I go this side, theta is 90. So initially the angle is 90. So I'm going this way. So 90 to 0. So this is what it is. So I can take the r, and then cancel it. This dx is equal to r d theta. So EMF is equal to mu naught I by 2 pi into 2 comes in the numerator into r comes in the numerator sine theta by 1 plus sine theta d theta. The integral of this from pi by 2 to 0. Okay, so again the 2 here gets cancelled, so the EMF induced is equal to mu naught I by pi. Oh, I is changing. Okay, so first I need to find out flux. So I'm finding out the flux only. So this is not EMF flux, this is flux. Okay, pi into r into integral pi by 2 to 0 sine theta into 1 plus sine theta. Okay, I will find this out. Okay, but otherwise when you look at the EMF of this only I will be changing, so the rest of it is a constant. So I have a di by dt and the di by dt is given to you. So if you look at it, okay, this is capital R. Okay, okay, no problem, I will sort that out. Mu naught I by 2 pi capital R plus capital R sine theta into, this is small r plus capital R sine theta into capital R 2 times capital R sine theta into R d theta. This is equal to flux. That is equal to mu naught I by 2 pi R plus R sine theta. 2 cancels, R squared sine theta d theta. Okay, so I have to do the integral of this. Now my problem is I won't be able to do the integral for this. So if somebody can help us out, then it will be easy. Pi by 2 to 0. Okay, but still we'll just leave that. Let's see. So it is mu naught R squared pi di by dt into integral of sine theta by r plus r sine theta d theta. So this should be the answer. This will be the EMF induced. Okay, so the question is the heat generated. Oh, heat generated. The current in the wire AB decreases linearly. Okay, OP is equal to OQ is equal to okay, so not many errors. This I stand is small r, this also I stand is small r, this is also small r, so all the r's will get cancelled. So it is mu naught r by pi di by dt integral sine theta by 1 plus sine theta d theta. They are asking you for the heat generated. Heat generated is the EMF, so 1 by r squared. This is the current, I squared r dt. So dt gets cancelled. I squared r dt. So the dt gets cancelled. So r gets changed. So it is mu naught square r square by pi squared capital R squared integral of sine theta by 1 plus sine theta d theta the whole squared into change in current into change in current with respect to time. That is the slope. Yeah, so the option D is ruled out. Option D is ruled out, so I just have to check if option B gives you the correct answer. Yeah, so the change in current, the initial current is I0. So I0, okay, so none of these is the answer. My answer is none of these. I'll just explain to you so that you will get it. First, they said there is a wire, and then they said there is a semicircular ring. They said this is the distance r. Okay. Then, so first you have to find out what is the flux through this ring. So the flux is equal to magnetic field. So I will just look at this portion. So from here to here, this is r. So this is r. This angle is theta here. So this is r sine theta. This is also r sine theta. So mu naught I by 2 pi d. D is r plus r sine theta. R plus r. Sorry, now I got it. Okay, r plus r cos theta. It is not sine theta. This distance is r cos theta. So it is mu naught I by 2 pi r plus r cos theta into this area. That area is 2 times r sine theta dl. The dl is again r d theta. So the 2 gets cancelled. So it works out to be mu naught I r squared sine theta by 1 plus cos theta d theta divided by r. Pi into r gets cancelled. So when I integrate this from pi by 2 to 0, when I integrate this from pi by 2 to 0, this will become ln 1 plus cos theta. So when you take ln plus cos theta, it will become ln 2. So the answer is mu naught I r ln 2 divided by pi. Ln 2 divided by pi. What is this? This is the flux. Okay. Now, if this is the flux, the EMF will become mu naught I mu naught r ln 2 by pi di by dt. This is the EMF. So in time t, it changes uniformly, right? So that is equal to I by t. So EMF is equal to mu naught r ln 2 by pi I by t. Okay, what is this? This is equal to the EMF into 1 upon r will give you the current. Heat loss is equal to I squared r t. So it becomes 1 by r squared mu naught squared r squared ln 2 the whole squared by pi squared I squared by t squared into t. So the t gets cancelled. So it has to be a function of 1 upon t, not a function of 1 upon t squared. So the others, I hope you are able to get it. Okay. So this is how you go ahead with it. This is the first page, that is the second one. Okay, so let me see what are the questions that you all have. Well, option D is given as right in the solution. Was found by the area of the triangle, sir. Di by dt. Di by dt, it's a uniform curve. It's a uniform curve, so it is the slope of the curve. So slope of the curve. A coil of. Sir, I'm not very much clear in integration, so I feel I'm unable to. Yeah, what can I do? Yes, you all have to learn integration fast. Basically, please understand that you have to clear the entrance exam. Your teachers can't. So we have to work on integration. Okay, let me go by one. Sir, in the last test, we had a question. So Soumya, I took up that question. I hope I've been able to clear as to how to approach it. Some error in the solution, I will see. So we can discuss solutions also. Yeah, we can discuss anything that I know. I'll be happy to answer. Yeah, the next one is I have sent you on WhatsApp also. I will see what it is. When 20 grams of naphthalic acid, okay, something is dissolved in 50 grams of depressors is observed. The Vent-Hoff factor for organic compounds, usually the Vent-Hoff factor will be 1. It doesn't dissolve But Harish, Venta factor is not there in our syllabus, so please don't worry about it. Generally, nothing will dissociate in benzene. So I don't think anything will dissociate in benzene. Depression. Okay, so you have to tell me what is the KF for this particular compound for benzene. If you tell me the KF, I will tell you. Okay, so there is one more question like 11 asking for flux. Please explain that question. I will do that. Why is the core of the transformer laminated? To prevent eddy currents. Sir, I am not very much clear. I will answer that question to you as we keep moving. A coil of inductance resistance connected to voltage current reaches half the steady state value in how much time? I'll answer. Sir, but option D is given as right. Di by dt was found by the area of the triangle. Okay, but Soumya, have I been able to give you an idea as to how to answer it? Yeah, so di by dt was found by the area of the triangle. How can they find out di by dt by the area? Current AB decreases linearly from I0 to T. If it's a linear decrease, there is nothing else. It is I0 by T only. There is no other. Mistake there. Okay, so yeah, so there is no other mistake there. So there's another question, it seems. Okay, let me just do one by one from here. Okay, then we'll come back and then do. Rectangular metallic loop width is given, is placed coplanar. The loop is moved perpendicular to the wire with some speed. The EMF induced in the loop when the rear end is at a distance of A. When the rear end is at a distance of A from this wire. Okay, so it is mu naught ILVB. Okay. Okay, so see, the way I can think about doing this immediately is, suppose L is equal to 0. Suppose L is equal to 0, the EMF induced will be what? Mu naught I V V B BLV, right? So mu naught I, yeah, so LV divided by 2C. Suppose what I will do first level is, suppose I have a wire here like this, and this whole thing is just a single wire. So this distance here is A. So B is mu naught I by 2 pi B. This is the magnetic field. B into L. L is B. So this is A, this is B into V. So if L is equal to 0, this should be the answer. Yeah, so let me see, if L is equal to 0, which of them will give me the answer? So if L is equal to 0, option A gives me 0, cannot be the answer. Option B cannot be the answer. Option D cannot be the answer. So that is the only possible answer. Okay, so sometimes by little smart work, it can be done very easily. How can they repeat the same question? Question number 11 and question number 13. Okay. Okay, ignore that. So there is an inductor, resistor given, battery given, are initially connected in series as shown. After a long time, the battery is disconnected. After short circuiting the points A and B, the current in the circuit 1 millisecond after the short circuit. Okay, so what you have to do is, you have to first understand what is the thing here. So here you have an RL circuit. So if you have an RL circuit, you have I is equal to I0 into 1 minus e power minus RT by L. Okay, so I is equal to I0 into 1 minus e power minus, I just substitute the values. So when I look at the values, R is given as 100, L is given as millihenry, time is given as millisecond. Okay, so it will become 100 into 1, so e power minus 1. So I0 into 1 minus 1 by E. So I0 E minus 1 by E. So that is the answer. Okay, I0 into E minus 1 by E. So when I look at that, disconnected. Okay. Okay, they are talking about the decreasing. So decreasing means that 1 minus won't come. When I found it out for increasing current, they are finding after a very long time steady state has reached. Once steady state has reached, that 1 minus won't happen. So for declining current, it will become I is equal to I naught e power minus RT by L. So when you substitute here, I will become equal to I naught by E. So that will be the answer. Okay. So that will look like the answer. The next one, what is this? Every third question is repeating. Okay. A long metallic ring connected to a rod oscillates freely like a pendulum if now a magnetic field is applied in horizontal direction so that the pendulum now swings through the field. Then the pendulum will be, what is going to happen, they are asking. Okay, so basically eddy currents will come. A metallic ring connected to a rod oscillates freely. Okay, it's a metallic ring. Okay. If now a magnetic field is applied, it's a circular thing. It keep oscillating with a larger time period. As it goes in, it will be pushed back. As it goes out, it will again be pulled back. So there are resistive forces. I'll go for this. It will come to rest very soon. See, what is going to happen for the pendulum is this. This is the circle. This is the magnetic field, right? So when it is magnetic field, when it is going in, the pendulum will be pushed out. Lenz's law. Again, when the pendulum is coming out, it will be pushed this side. Again, it will be slowed down. So the time period. So there are resistive forces. Resistive forces are forces opposite to the direction of motion. So it will stop after some time. It will stop. Okay. Now a coil of inductance L connects to the upper end. The horizontal conductor of mass M is projected at the time maintaining contact, all the time maintaining contact. A uniform magnetic field is this. The distance between the horizontal rails is L. The motion of the conductor is how much? Okay, so you have a coil connects upper ends as a horizontal mass. A B exists, a magnetic field B exists in the region normal to the plane of the rails. So now you are given have zero resistance. Okay, so yeah, so let's look at this. Let's see what is going to happen. So you have this, you have this, you have this, you have these rails. There is a magnetic field here. So we have no problem. So there is, it is given an initial velocity v. If it's given an initial velocity v, there will be a force in this direction. Huh? But there will be a force in this direction, but they are saying everything has no resistance. So what will happen is initially there will be current. So the current will build up a magnetic field here. Okay, the inductor will get charged. Once the inductor gets fully charged, then this will stop. Once this stops, again now that inductor will send a current. Now when the inductor sends a current, now there will be a current carrying coil placed in a magnetic field. So again there will be a force. So again it will come back. So what will happen is it will go forward and keep coming back. Okay, it will go forward and then keep coming back. So it will oscillate. So uniform, the distance between the motion of the conductor is non-uniform with sinusoidal varying velocity, none of these. So basically we have to understand that, first understand as the conductor moves to the right, there will be Lenz's law. They are not talking about any resistance. That's a problem. Having zero resistance. Time t horizontal rails, a uniform magnetic field excess. So you see there is going to be an EMF between the two ends. Because of that EMF between the two ends, the inductor will get charged. Okay, but there is no resistance. The motion of the conductor is uniform, non-uniform. Okay, it's a tough one because I have to learn it. I don't know it. I have to learn it. But if I have to tick something and then go, I don't see any reason. Basically, the inductor will be getting charged and discharged, charged and discharged. So there is some kind of a sinusoidal thing, but non-uniform exponentially. So I'll just go for this. For the solution situation in the given, the flux in the square loop is how much? There's an infinitely long wire. Yeah. So the flux is, we have done these kind of questions, just that our origin of it was different. So there is this, there is this. Current is going this way. So there is a magnetic field is going into the plane of paper and is coming out of the plane of paper. This A, the whole thing is B. Yeah, so we can find out. We can find out. So the flux will be, the flux here is equal to mu naught I by 2 pi. Let's call this as X. X. So X into this width D dx. No, whatever that L dx. The limits of the integral, on one side the whole thing is B, on one side it is A. So this is B minus A. So it the limits of the integral. Okay, so what you do is you have to integrate it from this side 0 to A minus integral mu naught I by 2 pi x L dx 0 to B minus A. So yeah, now you will get your answer. Okay, so this will become ln x. So it will become mu naught I by 2 pi L ln x from 0 to A minus again ln x from 0 to B minus A. So you can change this to ln x 0 to A plus ln x from B minus A to 0, and in which case you can remove this and then you can say it is equal to ln x B minus A to A. So that will give you ln A by B minus A. So mu naught IL by 2 pi. Yeah, so I think this is the answer for that. Let's see. So this is the one. Okay, yeah. So I don't know something. Let me see what is of interest to you and then answer. KF is Harish. It is direct application of formula. You apply the formula and then you will get the I value. Sir, please explain question 13. 11, 13 and 15 are based on same paragraph but different questions. Okay, let me see. Okay. 11, 13, 15. 11 I answered. 13. Okay, oh, question they have changed, is it? Okay. Long parallel this. The current in the wire AB decreases linearly from this thing. Find the magnetic flux through. We have done this, right? Then 15th one is where I think you are. Find the induced EMF in Pqrop as a function of time. You still want an answer for that? I think we did that, right? Okay, so I'll answer all the questions once again. This value, this distance here is r. This distance here is r. So mu naught I by 2 pi r plus r. This is r cos theta. R cos theta into r sine theta d theta. D theta is r dl. Dl is r d theta. Okay, what is this? This is equal to the flux. So integral of this will give you the flux. Theta value initially here, when theta is here, it is, this angle is 90 pi by 2. Finally, it is 0. So this will give you the flux. Can you just check this and then get me an answer? So I will do it for you. So it will be mu naught I by 2 pi r sine theta d theta by 1 plus cos theta. We worked this out no, just now. Okay, anyway, pi by 2 to 0. So it will become mu naught I r by 2 pi ln of 1 plus cos theta. So that is equal to ln 2 minus 0. Pi by 2 ln 1 is 0. So flux is equal to mu naught I r by 2 pi ln 2. This I think should be the flux. So there is some error in the options given. So none of these is the options for all of them. Yeah, but different questions. Okay, so that's another 11, 13, 15 are done. Now you are asking how it is sinusoidally varying. Okay. This is done. This is not the one. This is not the one. Okay, so you are asking me this question. Let me read it again. A coil of inductance L connects the upper ends of the two horizontal rails. A horizontal conductor of mass M is projected at T. At the time maintaining contact with the two horizontal rails as shown. A uniform magnetic field of magnetic B exists. The distance between this is 0. The motion of the conductor is what? Okay, nothing is given to you. So let us assume, okay, so there is an inductor here. Then there is this. This is given an initial velocity V. Okay, let there be some resistance R. We will later change it to 0. Okay, yeah. So there is an EMF. BLV is the EMF. So BLV is equal to EMF is equal to I into R plus L di by dt. Okay, I into R plus L di by dt. Then V is equal to, if a current I is going, BIL, so B squared L squared I, B squared L squared V. The current is going here is I, so force is BIL, so B squared I is how much? Okay, this is 0. Okay, if this is 0, LDI is equal to BLVT. Okay, okay. If a current I is passing through this, the force is BIL. BIL. There's nothing else. No substitution. If I is the current, so that is the force. So BIL by M is equal to dV by dt. Okay, I need some time, yeah, because the mass is also not given to you. Horizontal conductor mass M is given. Okay, so dV by dt is this much. V is not a constant; it's a function of time. The instantaneous EMF is BLV. So this is equal to acceleration. So V is equal to V0 minus AT. I can't say that also because I don't know if it's happening uniformly. Okay, so okay, give me time. Give me time, I'll answer. I'll work it out. Yes, so how sinusoidally varying? So Darshana, I will answer. Okay, next question is, Harish, you are asking me 20 grams of something is dissolved. What is your problem, man? You find out the molality, Kb into molality, so we will get it, na? See, in 50 grams of benzene, you are adding 20 grams of something. So in 1000 grams of something, you will be adding 400 grams of something. Okay. So find out what is the molality of this. The molality of the solution from what you're saying is C11H8O2. So it is C11H8O2, 11 into 12. So 12 into 11 plus 8 plus 32. So this is like 132 plus 8 plus 32. So this is 140, 172, so 400 by 172. So 400 by 172. So assume it is equal to 2.3, 23, 7 into 3, 1 carry 2, 14, 14, 17, 19, 9 carry a 1, 2, 1, 2, 3. So it is 2.3. Okay. So it is approximately 2.33, you put it, no problem. So now delta T is equal to Kb into 2.33 into I. So delta T is given to you. Delta T is Kf. So delta T is given to you as 2. 2 is equal to Kf values you have to tell me. Kf is 1.72. 1.72. What else is given? 2. 2 is equal to 1.72. So you will get 2 is equal to 1.72 into 2.33 into I. So when these things come down, so this will become 4. So I is equal to half. I is equal to half means it is associating. It is not dissociating. It is associating. It is associating. Associating means dimers are being formed. It is dimerizing. Okay, so that's it. Yeah, any problem there? Yeah, another one. Coil of inductance. There is a question. Coil of inductance. Yeah, coil of inductance resistance is given 2 volt. Half its steady state in how much time? Yeah, so simple. I is equal to I0 into 1 minus e power minus RT by L. So this I is equal to I0 by 2. Cancel, cancel. So 2 power minus 1 is equal to, or let it be, 1 by 2 is equal to 1 minus e power minus RT by L. Shift, shift. So you will get 1 by 2 is equal to e power minus RT by L, or 2 is equal to e power minus RT by L. So 2.303 into 0.301 is equal to RT by L. So substitute there. So this will become plus. Okay. So substitute there. You will get T is equal to 2.303 into 6. So 0.6909 into L by R. So everything is given to you, substitute, you get your answer. So I is equal to I0 into 1 minus e power minus RT by L. I is equal to I0 by 2. So I wrote this, then I rearranged it. I took this side, this side I got half, then I made reciprocal. So minus became plus. Then I took log, then I remember my values for log 10. So I just substitute it and I get my answer. Is that okay? Yeah. For chemistry, I had questions from, oh, you took too early in the morning. That's the problem. So they made a mistake. Hence, next time onwards, please take it after 10 o'clock only. Okay, don't take it early in the morning because they do work till late in the night on Saturday, and then I can see it only on Monday. I mean, on Sunday morning. Yeah. Okay, next question. Yes, others, please ask whatever other questions you all have, please ask. That question, the specific problem there is no resistance. So what we will have to do is we'll have to assume some resistance, and then we will have to tend that resistance to 0. Okay, we will have to tend the resistance to 0, only then something will come. Okay, so there is a, we can test, I got it. Let's analyze that other question, the 13th question, and test. Radius is small r from the long wire. Yeah, I think my solution is correct, but let us see. Let us end test and then let us look at the solution. Let us look at that solution and then see. There may be error in the solution itself. Heat generated. No, let us not bother about the heat generated first. Let us bother about the this is an error because it can't happen that we got 2 questions right and the third question is wrong. The 62, I hope you understand. I was explaining to you the logic. This is A, not L. Okay, so that should be A. But otherwise, I hope you understand the logic and how the logic falls in place. Okay. So all that I did is I assumed that the rectangle has no length. That is that L is 0. So if L is 0, then there's an EMF mu naught I L B. So D obviously should be the right answer, not C. Here heat generated in the region as a function of time. Yeah, we did the same thing. We also did the same thing, but it is clearly a ln function. It is not pi minus 2. So there is an error there. Okay, so I hope you are able to see that. Okay, so what about the other two? We answered the other two. I don't know. I guess this question and then it comes out to be right. So d phi by dt is L di by dt, that is BLV. So the flux is changing. So it's non-uniform motion. So non-uniform with, okay. Okay, so that was the question. Oh, I guessed it and it's turned out to be right. Excuse me. Yes. Sir, I have a big question. I'll post it on Learnity. Yeah, I'll be able to do. If liquid A and B form a non-ideal solution, then delta G mixture is equal to 0, delta H mixing. If they form a non-ideal solution, then anything can happen. Delta H mixing is 0, delta G mixing and delta S mixing both are 0. Delta S mixture, if S and A, B form an ideal solution. If they form an ideal solution, then delta G mixture, delta option B is the correct option. Delta H is 0. If they form an ideal solution, delta H is 0. Yeah. So next. If they form an ideal mixture, Harish, delta H is equal to 0. The reason why delta H is 0, because there is no interaction. If they form an ideal solution, there is no interaction between molecules. If there is no interaction between molecules, there is no bonds formed, no bonds broken. No bonds formed, no bonds broken, delta H is 0. Okay. Then any other questions you all have? Gibbs free energy. Delta G is equal to delta H minus T delta S. Okay, this is equal to 0. Delta G is not equal to 0 because delta S is not equal to 0. So whenever you are mixing, delta S will increase. So it will not become equal to 0. So delta G will not be equal to 0. Delta H will be equal to 0 because there is no interaction between molecules. Because there is no interaction between molecules. Delta H is equal to 0. But delta S is not equal to 0, so delta G is also not equal to 0. Yeah. The current in the circuit is increasing at a rate of 4. So this question from test, the current direction is given from negative terminal. Please explain it. Okay. 1 minute. The current in the circuit increases with a rate of 4 ampere per second. The charge on the capacitor at an instant when the current in the circuit is 2 ampere will be how much? Okay, so the question is like this. There's a resistor, there's a capacitor. Then it is given to you the current is increasing at the rate of 4 ampere per second. Okay, so here it is 4 volts. Here it is 4 volts. If it is 4 volts here it is 2 volts. They have asked you for this potential. What have they asked you? The current in the given circuit is increasing at the rate of 4 ampere per second. The charge on the capacitor at an instant when the current in the circuit is 2 ampere. So current in the circuit is 2 ampere. So now this is 4 volt. Current is 2 ampere. So this will become 4. So 4 plus 2 is 6. 6 minus 4. So, so these two will be opposing this. So because of that, the current direction will be from the negative, not from the positive. So it is 2 ampere. So 2 volts will be the current. So current is 2 ampere, but the potential difference across capacitor will be 2 volt negative. So if the potential difference across the capacitor is 2 volt negative, means you can find out C is equal to Q by V. So it will become 3 by 2. So you will get see here it is 4 volt, here it is 4 volt, 2 volt. So here it should be minus 2 volt. So C is equal to Q by V. So Q is equal to C into V. So it will become 3 into 2. That will become 6 coulomb, 6 microcoulomb. Positive negative will take care of the terminology. Yeah, so I hope this is understood. Okay. Now that research associate. So the research associate wants to create a solenoid. Okay. So he wants to create a solenoid over a particular length. Now, when he wants to create a solenoid over a particular length, they have given to you. You know that L is equal to mu naught n squared L pi r squared. Okay. So Now they want a magnetic field. Suppose they want a magnetic field over a distance y. Now the diameter of the wire is given to you. So the number of turns are n in that length. So in that length y, capital N number of turns will be there, or this is equal to capital N into D. So from here the number of turns is equal to y by diameter, because you're going to keep the wires close to each other, right? So assume this is the case. So only if you have all the three informations you will be able to do. So now over the length over which they want a uniform magnetic field, that will define the L value. The total number of turns is equal to this. So n divided by y is equal to 1 upon d. Okay, what is n divided by y? N divided by y is number of turns per unit length. So that seems to be one more unknown. So that number of turns per unit length will simply be 1 divided by d. Make sure that your units are correct. So from there you will get the value for n square. Okay, now this is known, this is known, this is known. Now you will be able to calculate the rest of it. So I repeat, if the wires are next to each other, totally we will need, that is when you will need capital N number of turns is equal to y by d. Okay, so y is that distance over which you need it. So yeah, but otherwise I feel that if you cannot assume that the wires are next to each other, you can't do this question. So the data is missing. So that L value has to be given. L value has to be given so that you are able to assume how many N's are required. Yeah, so that I have explained to you. Sir, a short circuited coil is placed in a time varying electrical power is dissipated due to current induced. The number are all quadrupled and the wire radius is half. The electrical power dissipated would be half or same or quadrupled. I hope you understood the previous question, why current is drawn from the negative terminal, because overall potential seems to be higher than the applied potential. So Kirchhoff's law. So by Kirchhoff's law, the current will be drawn from the negative terminal. Okay, then a short circuited coil is placed in a time varying magnetic field. A short circuited coil is placed in a time varying magnetic field. Okay. Electric power is dissipated. The number of, okay, so the way we can go ahead with it is, first understand that there is a coil. So suppose there is a coil of having n turns in a time dependent magnetic field BD. So NBT into pi into r squared. This is going to be the flux. So n pi r squared dBT by dt will be the EMF. This by r will be equal to I. So I squared r will become n squared pi squared r power 4 dBl by dt the whole squared divided by r. Okay. So this is equal to power dissipated I squared r. So yeah, by r. This is the power dissipated. So now they are telling you that if the coil number of turns are quadrupled, so 4, so 16 times, the wire radius is halved. Wire radius is halved means the area resistance will change. Okay. So now they are saying that the number of turns will be quadrupled. So R will become 4 times. Also, this number of turns will change. Okay. Then R is equal to rho L by A. So area is again R squared. Now this radius is also halved. So this R resistance will also change 4 times. So it will become 16. So these two will cancel. So no change. Okay. You forget it. You do look at what is understandable. Short circuiting is ensuring that there is a current in the circuit. You say whenever you connect a circuit, you say you short circuiting it. Short circuiting is ensuring that there is a completed circuit. It's a forcible way of saying that I completed a circuit. Yes. Yes, any other questions? People have gone out. Yes, Krishna, Lydia. Okay, so if you all have no other questions, fine, we will stop. See you again tomorrow. I'll send you one list of important questions for the board exam. Tomorrow I will send you. I mean, today at night I will make it. Tomorrow I'll send you. Meanwhile, I have put a challenge that I won't be more than 1 day late on doubts asked in QDB. So you are free to ask. Till yesterday I have cleared all doubts. Yesterday 4 o'clock I have cleared all doubts. So from 4 o'clock till today morning I am seeing there are some doubts which I'll be clearing it by tonight. So there is a challenge. So please make sure that you can also challenge me. Yeah. That research question you are asking. Okay, I have not seen the full question. Okay, so I'm just explaining to you the question. The question is that somebody wants to create a magnetic field in a particular region. Okay, so if you want to create a magnetic field in a particular region, now you are going to pass current through this wire. So when you are going to pass current through this wire in a particular region, one magnetic field will be generated. So you want to know over how much distance you want to create a magnetic field. Okay, if you don't know over how much distance you want to create a magnetic field, then you can't do it. Yeah, so first understand over how much distance you want to create a magnetic field. Suppose you want to create a magnetic field over a distance L. So in that, suppose the number of turns per unit length is N. Then the total number of turns there, yeah, in that zone will be N into L, and the number of turns per unit length is N. Now the inductance value L is equal to what? Mu naught N I then pi R squared total number of turns. Okay, so now this total number of turns is equal to N into L. Now there is one more thing. You are going to place the wires next to each other. So when you're going to place the wires next to each other, suppose over a distance L you need a strong magnetic field, then in that L, suppose there are totally capital N number of turns. So that N divided by L should give you small n, the total number of turns per unit length. Okay, so in this you will get it is equal to mu naught, yeah, N squared pi R squared by L. This is the inductance value. So based on this, now most of the data is given to you. If you combine the 3 questions, all the data will be given to you. So look at the 3 questions, make sure that you are getting this. From the one question that we saw, all the data is not there. So you have to combine the 3 questions and then make the data. Okay, so I will rectify the question. I'll rectify the question. I know. Some data is missing in that. That's what somebody asked me, and I told you that the data is missing. Don't worry about it. So I'll do that. I'll work it out. I'll rectify the question and I'll present it again. Yes, in Learnity, I am making sure that all the questions are answered within 24 hours. So you can test me. So you can put your question and make sure whether your questions are answered or not within 24 hours. Okay. Okay, good, fine. Carry on. Read and then message. If you all have any doubts, please put them on Learnity. 24 hours. Within 24 hours, all your questions will be answered. Okay, if we know the answer. If not, also I'll tell you. Okay. Yeah. Bye. Okay. Welcome. Welcome.